Welcome, ladies and gentlemen, to our talk on modular machine design through decentralized automation. My name is Aurel Buda. I work at Turck in product management, and today we are going to talk about modular machine designs, why you should care, modularization not just in hardware but also in logic, with the overall goal to reduce your total cost of ownerships while being flexible and quicker, get more things done in less time, while being prepared for adaptations and extensions.
My name is Sai Seidel. I'm working in corporate marketing, and I'm also talking to you about that topic. And I want to start with a infrastructure picture we want to show to you. So if you look into that proven infrastructures you have today in your automation hierarchy, it's quite simple. It's a pyramid, as you know, as you probably work on. Which is working in the end, which is working for a long time. But as we all know, you have a design of your machine which will be quite monolithic. You don't have the flexibility to change some things if you want. So as soon as you get a customer requirement to change something in your machine, to adapt something, to improve something, it's getting a little bit harder because you have to start on the top and then you have to go down. And the control is the heart of the machine. As a lot of customers know, told me they have the control in the middle, in the core of the machine. Of course, the whole stuff is built up in IP20, usually in a big part of it, and that makes a quite big footprint of the machine because the cabinet is quite big, as you know. And the data flow in that whole automation is quite strict because you have that hierarchy, and there's no way outside of that hierarchy. And so we have a very strict data flow. Of course, in the end, very costly, can be very inefficient in the end, and you have to take care how to improve something. And if you think about how you get up a modern infrastructure, here, maybe you can take this part.
Yeah, thanks, Sai. So it's like what we saw over the course of especially the last 5 years or maybe 10 years, along with technology trends of industrial Internet of Things and Industry 4.0, is that customers step by step get away from this very static pyramid architecture and automation. They are not fully at a fully interconnected cyber-physical system yet, but what we see today is that customers take much more care about modularization, breaking their system into modular standardized components, routing communication that is meant to control the process still through the PLC. We see some customers that are using decentralized automation for that as well. And we are going to talk about that in a minute and why that is a good idea in certain applications. And we see that for instance, new use cases like asset management, maintenance, things like condition monitoring are not necessarily only routed through centralized PLCs anymore. We see that those systems like SCADA, MES, or even this cloud are connecting in parallel to the PLC, to connected to devices that are located in the field for good reasons, and I will explain that later on as well. So that is what we see right now, and why should you care? So one thing is that as soon as you touch or start to design or break your system into individual standardized components, you are able to reuse those modules. So that's the overall idea of modular design. It's like design once, use multiple times, and that will make you faster at the end as soon as you can reuse things. You will be much more flexible. We supported a lot of customers within the last 10 years in modularizing and standardizing the individual parts of installations and machines. And many of them already have kind of a toolbox right now out of which they can orchestrate larger systems. So it's more like orchestrate and configure and not start over from scratch and redesign everything again. And every software developer is supposed to know that. So modularization in software started in the 70s. If you work on modules and components, the test vector is much simpler and much smaller. So it's much easier to test, validate, and maintain those devices and hand them over to new stuff. And yeah, of course, coming back to the Industry 4.0 use cases like condition monitoring is a really hot topic. having modular architecture, it's much easier to analyze and investigate individual parts of your installation and optimize them much easier and quicker in incremental agile steps.
Very oriented in the end. And that makes the next step, of course, as well possible. You already mentioned that cyber-physical system. So in a world after that decentralized stuff, or following that decentralized stuff, we will have a very connected, very IoT-based world where everything is talking to everything. So it's a vision that the industry has for some years now, and we're working on that to get further and further to that world, that we go away from that centralized, very monolithic machines into modular machines with a very high connectivity inside. And this is what you really call industrial IoT in the end. So talking about that, how does the data strategy look like in a modular machine?
Yeah, that's a really good question, and that is a very important key. So decentralized automation in general is a key technology for efficient sensor-to-cloud communication. But it's not like every data has to be communicated to the cloud. You don't need tons of data in your cloud. That's a potential security attack vector if you communicate too much. So, and there come smart and intelligent devices into play. So where we have like, I mean, Turck is offering a rich set of sensors. We have remote IOs, and we have the edge gateways offering all the connectivity to connect to individual systems. However, more or less any of those devices has logic capabilities inside. Some of them are optionally. You don't have to use them, but you can use them. And that makes it a world of edge controlling devices which enable you to apply smart filters to your data, which enables you to pre-process things. And that, once again, enables you to individually select the correct data to forward to the cloud. So what is meaningful in the cloud, what is not meaningful in the cloud. And that, at the end, it's kind of the combination. So decentralized automation and modularization is on one side. It helps you to reduce costs, reduce the total cost of ownership, and it sets the infrastructure for all the modern IoT and Industry 4.0 use cases that you would have in terms of sensor-to-cloud connectivity.
Yeah, cool. That's exactly what I say. When I say IoT, industrial IoT, especially in our case, it is that decentralized units in a machine. You build up modular design. You bring in the whole automation and the logics into the machine and not into one central piece of a cabinet or something. And then you start to think flexible, to think smarter, to think modular, and your machine is getting modular in the end. If you think about the benefits in the end, what are the key benefits of decentralized automation, of using that concept?
Well, there are several benefits, but one benefit that we already mentioned, of course, is shorter time to market. So it's like, I mean, it's a way to get there, and it's not like you don't have to break out your whole system at once in modular components. You can start incrementally and step by step. But once you have a toolbox of modules that you can reuse, being it in hardware, software, and logic. So it usually for us, it starts with hardware, but it doesn't end there. So the ultimate goal is to break it down into hardware, modules in hardware, and modules with smart logic. And it's once implemented, we use it, you are quicker in that. You can orchestrate larger systems out of that, which is really important. So the overall installation in your whole machine can be set up much quicker. You can scale up much more without less persons if you think in modularization, in modular worlds. So the problem is that we don't have enough skilled people to scale as much as we want to, so we have to find measures to overcome that, and modularization is a key, and decentralized automation as well. Another thing is, I just mentioned it, it's like if you break your system down into smaller, let's say, easier to maintain components, the knowledge transfer from person to person is much easier. So I guess every one of you knows that, and we have that internally as well. We have people that work for years for us. The most experienced people get stuck in their former projects, and they are not available for our new innovative stuff or projects, because they are the only persons that know how the old things work. And that is the situation we want to overcome. Breaking your system down in smaller, maintainable components and modules helps you to hand over and maintain those things with different peoples. And the same is true with testing the component. Having a large monolithic system is like, it's nearly impossible to reach like a test coverage of 99%. So we would never reach 100%, by the way, but breaking your system down in small components, it's really simple to reach a really meaningful test coverage up to 100%. And that, once again, so one of the major benefits is that you get a more reliable, better tested system while being quicker.
What you didn't mention is IP67.
Oh.
And this is part of our DNA at Turck. So what our company is doing, we focus on IP67. Of course, there are some more technologies in the end, but everything we do, and especially in the decentralized automation world, IP67 is a very key to success. And if you think about what Aurel said a minute ago, you have a hardware part and you have a software part in your modularization. The software part is the stuff he was mentioning a second ago, but the hardware part in IP67 is really important to lower that machine cost in the end. And this is the real benefit in the end for the customer, for you. So you reduce your installation time, you reduce your installation time of software, not only the hardware. You reuse things in the end. You can use the same modules, the same hardware for a different kind of use cases. In the end, I talked about the footprint a second ago for the cabinet. And if you imagine your cabinet is getting smaller, your footprint will also get smaller, that's for sure. And yeah, this is something we can offer just by using that decentralized concept in the end.
Absolutely. So, of course, it all starts in the hardware. IP67, wound connectors, standardized connectors for power, data, and technology in IP67 directly mounted on the machine. That's absolutely great. And another aspect is like, as I said, your modules and your machines will become much more reliable since you have a better test coverage. At the end, that increases your availability of the system in general. And as soon as you offload logic into the field, which is, it's not always easy to get there, but as soon as you have that, you have kind of individual systems running on their own, which are not dependent on your central CPU anymore. And that increases availability a lot. So in several applications, we see like redundant central controllers that control huge amounts of devices and data. But that's a critical point in terms of availability. As soon as you can offload things that work individually, you once more increase availability of your system. So if one system falls out, the rest still operates as it's supposed to be.
Good point. Coming to applications in the end. So you were talking about big machines and so on. And we had that one example in the logistic industry because we have great or very big plants in the end, but we also have the suppliers for that plants. And we have one of that guys who was having a quite monolithic designed machine. And his issue or his requirement was to get more flexible, to get more independent in the end. So he has 10, 20, 30 customers, I don't know, but he will have many customers, I hope for him. But this guy has to adopt changes for that different customers. And this adopting is really taking a lot of time. And as soon as you're getting into the modular world in your machine, you can do that whole change process in a very smart and quick way. And this is something he was requiring. And in the end, we built up, the customer built that up, and we helped him to get from a monolithic point of view to the modular machine in the end. And now he has a design which is really flexible and, of course, creates a very high value in terms of time to market, high availability, and so on.
Yeah, absolutely. That was great. And by the way, so the customer is not yet there, but his vision is, so it is related to a cold storage transportation system. And nowadays he's charging for the machines, for the installation that he's offering. But his vision is to transport as a service based on his modular installation systems. Right. Yes, and as you're talking about logistics, we have another nice success story from logistics. This one is about conveying systems, but in a very special way, and it's not limited to, but often used in around e-mobility. For instance, we have one example from battery production, where the conveyors would transport individual parts from assembly stations to test stations. So the customer we dealt with in this application, he made up his mind on how can I pull out this error-prone stuff out of my conveyor track, and he implemented a passive conveyor track with smart conveyors. Those smart conveyors have let's say, to a certain extent, even predictive maintenance capabilities. But in case one conveyor is broken, conveyor cart is broken, he can pull that off the track and the whole system still works. He just has to replace one conveyor cart. And that's really interesting. And that customer standardized on a, let's say, very small set of modules that he needs to drive that conveyor application. So he has these smart carts, he has stations to push out carts and load and unload stuff, he has turntables, and all of those are individual modules controlled with logic. And those ones get usually integrated into a larger system, into the installation where main PLC runs. And one of these super benefits the customers had is next to having a modular set and being able to extend and adapt the system as well as in the application story I just mentioned. They were now able to offer very clean and easy to understand interface towards the integrator, because in the past they always had trouble with the knowledge transfer to the integrator. So the integrator in the past was responsible to control large parts of the logic around this e-card system and the conveying system, which is not easy. So there was always a gap in knowledge transfer. And the next thing that was really challenging was doing operations whenever there was an error. The final customer always reached out to the provider of the e-card system, but at the end it turned out that the integrator made the mistakes. Nowadays he controls his part of the logic, offers a clean interface towards the main PLC for the integrator, and all boundaries are absolutely clear. The knowledge transfer is much quicker, and in case of support or issues, the end customer usually knows who to contact. And that's a great story as well.
It's a good example, yeah. And these things are controlled by IP67 PLC, right?
Yeah.
That code is this PLC, and
Exactly.
the first one as well. We already saw over there, we have IP67 based blocks where you can do a whole PLC world based on codices. But to get it a little bit smaller, we also have applications where we don't need that very big, high-level PLCs. We can also do that with a quite smaller logic onto our IOs. It's called FLC, Field Logic Controller Program by Program, in our interface called RG. And with this, you can provide little logics, little applications inside of a smaller unit in the end. And you can also do some things like a factory acceptance test. In pharmaceutical industry, for example, we have that issue that customers ask us. We have big plants where we have to put in a lot of skids in the end, and pharmaceuticals are working with that skids to have an easier process in the end. So this is the first step to a modular machine in the end. And they have that issue that they have to test the skids, and we can provide them the possibility to test it independently and then put in the tested system, the tested unit into the whole plant, and the rest the end customer has to do is only, more or less only, the big test of the whole setup in the end. And he doesn't have to test the single units in the end. And this, of course, it's a high value for that time to market in the end.
Absolutely.
And so to finalize in the end, the basic key features of decentralized automation at Turck. As I said, IP67 is one of that very big topics we have in our portfolio. You lower your footprint in the end. You create a high value in terms of design, in terms of costs, in terms of installation costs in the end, and you go the first step into the modular world.
Yeah, absolutely. So hardware, modularization in hardware, using IP67 technology and wound connectors is absolutely the foundation of modularization for us. And it starts with the sensor, goes to the remote IOs, edge controllers. We actually have everything in IP67 available for those applications. And but for many, they think it stops there. But we go one step further. and already have the technology to add intelligence to those devices. And one thing that's really interesting and challenging, and I know that many of you will have trouble with that, or thought that this is a challenge that's not easy to overcome, is as soon as I break my system down into modules and try to add logic, it turns out that where I, for instance, in the past used to use standard remote IOs, I need something that has logic inside now. And that is in certain applications, so it depends on the complexity of what you're going to do, might be a little bit too expensive. So that adding logic to really small components may add too much cost because you have to invest in kind of small PLCs or what have you. And that is where our, you just mentioned it, RG, field logic controller capability comes in. So what we have on all of our block IOs, and being it IP20 or IP67, we have the optional capability of adding logic to those devices at the cost of a remote IO. And that really enables you to add logic even to your smallest components without increasing the cost. So in best case, you already save cost due to your modular design and using IP67 technology, getting rid of your cabinet being smaller. And at the same time, we enable you to add logic whenever you want to. The next level is we of course have the technology for more sophisticated and comprehensive modules. Those are the application stories we just referenced out of the logistics, where they used our IP67 edge controlling devices with PLC capabilities. So those ones have enough performance to serve even, let's say, complicated applications.
Yeah, they're full-blown PLCs in the end. You can just control the whole application if you want.
Yeah.
And you mount that PLC onto your machine. You don't have to do a cabinet and so on. And this is something where we hire the flexibility of our customers themselves. So,
absolutely.
Yeah.
Yeah, and that brings us to the end. So as we said, so it's in the DNA of Turck. So a lot of what we design is driven by the fact that we want to support you in modularization, in decentralized intelligence, in decentralized automation, and it doesn't stop at the hardware. Turck can offer you smart sensors, for instance, with IO-Link, with other interfaces, but we can already generate data coming from the sensors in a digital fashion. We have all the technology to process this data, pre-process this data, connect it to any superordinated system, even up to our own cloud service. But we can connect to other cloud services as well.
So yeah, Turck is your global automation partner. And if you want to have questions for us, we are there in a minute if we go into a chat. Thank you for listening. Thank you for your attention.
Thanks.